Yeah, well, I mean, sort of. I think it's mostly correct to call me a researcher. I'm not currently employed as a lectureship, but I'm still on that because I did some teaching before, so that's what it says in the catalog.
Oh, gotcha. Okay. And it's at Uppsala University, which is also where he received his PhD in 2019. After his PhD, he did a postdoctoral fellowship at Warwick University with Nick Chater, where he studied approximations to Bayesian inference using sampling, which I believe is partly related to your talk, which is called the elusive rationality of low probability, high impact events. Did I get that right?
Yes, absolutely.
So before we begin, we'd like to acknowledge the traditional custodians of the land, the Wurundjeri people, and pay respect to their elders, past, present, and future. Now, go ahead. Yeah.
Well, all right. Thank you very much, and for that wonderful introduction. And of course, thank you very much for allowing me to come here and speak to you. And thanks especially to Andy for helping setting all this up. It's really great to be here, I have to say. It's been in Melbourne a few days now, and I really like the place. I don't know. It just seems very well. I read somewhere that it's considered one of the most livable cities in the world. And before I came here, I was like, what does that even mean? I mean, what is that? But after spending a few days here, I can sort of see it. I definitely. So yes, I will be speaking today about the what I've chosen to call it the elusive rationality of low probability, high impact events. And I was actually going to. There we go. I was actually going to start to give some short bio on myself just to put things in context, but of course now Adam did it rather nicely already, so I don't really have to do that. But yeah, PhD at Uppsala University, where I'm also currently based, postdoc at the University of Warwick. And currently I'm doing a project on low probability, high impact events. It's a 3-year project, so it's a stipend that only really supports me, so sort of a postdoc grant type of thing, and I'm more or less halfway through it, so at the 1.5-year mark. And I also mentioned just briefly that my PhD thesis was on combining estimates of marginal probabilities to estimates of conjunction between events. And of course, the postdoc at Warwick, as Adam mentioned, was about sampling-based inference, sampling-based models of Bayesian inference. Specifically, I looked a lot on probability estimates and sampling-based model of that. And now it's a project of low probability, high impact events. So as you will have noticed, probability is sort of a recurring theme here, and it's something that I've been very interested in ever since I started work on my PhD. Obviously, mostly about how people understand it and how people behave in situations under risk and uncertainty, but also very much as a mathematical statistical tool, and also the sort of philosophical conceptual basis of it, which I will actually talk a little bit about today. And I will just briefly sort of mention some other stuff I'm doing, and that's mainly just not take a lot of time, but mainly just so that if any of this seems interesting to you, then feel free to chat me up after the seminar, and we can talk about it. So one thing is I'm working on a model with some collaborators at Uppsala University, where we're using error distributions to sort of delineate between cognitive processes. It's based on Egon Brunswick's idea about intuitive processes being rather approximate and therefore normal distributed error, and analytic processes being more exact deterministic, and therefore we have a leptocurtic distribution. And it's a part of a general theme about using noise as information to get more knowledge of it. Also still collaborating to some extent with my old lab group at Warwick with the sampling based models. Personally, I'm a big fan of everything sampling. Basically, I do think that it's one of the best ways to bridge sort of the Bayesian perspective on human behavior and human rationality, which I think is a very, very strong perspective, and sort of combine this with the biased type of behavior that we do see with people. And this I want to mention specifically as well, because I am personally rather excited about this. This is a recently funded project, huge project, lots of money, based in Sweden, that is aiming to look at evidence-based criminal law, meaning that trying to get a multidisciplinary perspective on weighing of evidence, making of verdicts, and try quite simply to reduce decision errors. So we have a lot of people from a lot of different universities. Couldn't fit all of them here, obviously, so Moa would have to just represent all of them as a project leader. And of course, since it has all to do with how people take in information and process it and make decisions based on it, cognition will be a through line to all of this, which is where I come in, basically. And it's just started up, so I don't have much more to say about it. But I do have a webpage there, and I will put that up on the last slide as well, so you can all sort of write it down if you're so inclined. But what I will be talking about today is this project that I have going on decision making in the context of rare and impactful events, which was the title on the project when I originally suggested it. I've sort of moved on to speaking about low probability, high impact events, just to find a sort of a common term for this. And this whole project is basically three different parts, one could say. It's first, and you'll notice that it's all theoretical work here, so I don't have any data collection of my own. It's more about finding the basis to move research forward from here, hopefully. So the first part is to get some overview of the literature, try to figure out what we know and do not know about how people behave in the context of these events. Short answer there is that we don't know all that much, really, because this is not exactly the kind of events that are generally studied in JDM research. The second part is, and that part is pretty good. Well, I won't say done, but at least the manuscript that was supposed to come out of it is more or less ready for submission, at least. So what I'm going to speak about today mainly is this part 2 here, where I want to do sort of a theoretical analysis of various rationalities, decision frameworks, basically how to look at these events from a sort of a more higher conceptual level. And then the last part will be to take the findings that I will hopefully have from these two first parts and apply it to human behavior in the context of the COVID-19 pandemic, and see if that can sort of inform our understanding of how people behaved, what decisions were made and not made, both at a global, national, and individual level. So, yes, and I should also mention that I am pretty much starting work on this part 2 now, more or less. So this will be very, very preliminary stuff. I will certainly not have any data to show or anything like that, but mainly just introduce some of, well, as I mentioned in the abstract, some of the unique complications that I think we run into when it comes to these particular low probability, high impact events, and sort of some ways of potentially dealing with them. I won't say solutions, because I don't think they are really, but some sort of areas and venues that I think might be somewhat promising. But this is, again, it'll all be very, preliminary. So I'm very welcome to just come in with any kind of feedback now or later. If at any point you can just interrupt me, post questions or anything. No problems there. And I think I have quite a bit to go through, I'm realizing now, but I'm going to try and keep it as understandable as possible and not skim over too much of the important stuff. But if I end up speaking too quickly or just rushing through things, just let me know and stop me, and I'll go through it, more clearly if necessary. So, so I'll start with some operational. That's a really tricky word. Start with just making clear what I mean when I talk about low probability, high impact events. And here you'll notice that I've sort of intentionally left the definitions rather vague, because I do not want to sort of limit myself and limit the discussion unnecessarily. And I do feel that it is still rather clear what we're talking about. But in general, I would say that I'm interested in events with a probability that is much lower than 1%, which is certainly much lower than what people generally look at in JDM and cognition research in general. I'm not really making any assumptions of how the probability are conceptualized, although I think that the conceptualization is important. I will mention that later, but basically it doesn't really matter if this is a well-defined, some objective probability, whatever that means, or if it's just a subjective impression of something being very unlikely. We'll include all of these. High impact also defined as just something that has a major effect on the lives of those affected by the events. So also in this situation, I want to make clear that I'm looking at, and I mentioned COVID-19 as an example, obviously an event of global magnitude, but it doesn't have to be. This can also be on a more personal perspective. You yourself ending up, being in a car accident or whatever. I actually have an anecdotal thing. One of my friends, I learned just the other day, he has been grinding his teeth a lot and suddenly got extreme toothache. And it turns out, he went to the dentist, sort of an emergency thing. It turns out he's going to have to, he's grinded his teeth down so much, he'll have to replace quite a few of his front teeth. And it's something, he'll be fine, no doubt, of course. But he's in quite a lot of pain, and obviously, dental surgery is very expensive. So it's all rather miserable. So, but it's certainly not something that, it affects his life a lot, the lives of those immediately around him, obviously, but it's not something of global magnitude. But this is also something that came very unexpected, and therefore I think qualifies. So just as an illustration for the sort of the things that I'm talking about. You'll notice also from my examples that I'm going to focus on negative events. That is negative events with negative impact. And that's mainly because I think that those are, they're more salient, just generally, but also because I think that those are probably the more important ones. I do find it more relevant to focus on protecting from disaster than preparing yourself for sudden windfalls and sudden fortunes. Because if they occur, we'll probably be fine anyway. So also just briefly mention that when we talk about low probability events, the term black swan is all often sort of mentioned, and I just want to mention that I don't really equate these because in Nicholas Nassim Taleb's original definition, a black swan is an event that comes as a surprise, has a big impact, and can be sort of explained and rationalized after the fact. And this comes as a surprise is sort of the main part of it. And because of that, if you go by the technical definition, then a black swan is only a black swan after the fact. And I don't want to limit the discussion to that. Not to say that black swans aren't a part of the discussion. They certainly are. I just want to make sure that they are not equated. Low probability, high impact events can result in black swans, but they are not the same. I will be bringing up more of Taleb's ideas, though, because he does have quite a lot to say on the subject. So just quickly go through some of the general results that I got out of this literature review. as I mentioned, not too much that we do know about it, but we do see that it's certainly the case that people tend to either, when it comes to these events, either overestimate their probability or discount them entirely, in the sense of, acting, either reasoning that, oh, won't happen to me, don't care, won't wear my seatbelt, stuff like that. Or just on an implicit level, something they don't consider at all. This in itself is probably not particularly new, and it makes a lot of sense if you think about it, because very low probabilities require quite high precision to deal with them, and it's reasonable to assume that just as we're not made to distinguish sort of nanometers or micrometers for in our perception, we would also not be expected to distinguish between tenth of a percent even, or even lower than that. But what's, I think, more important, more interesting to put in is that this, whether people discount or overestimate events, it apparently does not have much to do with the relative probability or impact. Something that Andy demonstrated quite ingeniously, I have to say, in one of his papers. So the question then is, of course, well, what does govern this? And there are quite a lot of factors that have been found in research that might affect this. Heuristics, certainly, availability and effect heuristics, been a lot written about. Slovic has some very interesting papers on that. Ido Erev has recently been discussing more about reinforcement learning in the sense of people's behavior in this sense. Again, you sit in your car and you know that, well, never been in an accident, I'll be fine. And every time you're not in an accident, that reinforces that conviction. And of course, would be remiss if I didn't mention sampling. And if you assume, like we do, we meaning me and the guys at Warwick, that probability estimates and the like is based on sort of a sampling, an internal sampling process with small samples, then really overestimation or discounting is the only options. Because say that you draw a sample of 5 and you use that for a probability estimate, more or less. Then the only options really are either 0, meaning discounting the event entirely, 0 probability, or 1 in 5, which it would, in these cases, definitely be a strong overestimation. But again, we don't really have much knowledge about, all of these presumably play some part. But we don't really know enough to have any kind of systematic prognosis or prediction about people's behavior, which I think is probably where we should be focusing our energy if we're interested in knowing more about how people behave in these events. And I think we should be, obviously. But that's that. What I'm more concerned with right now is, of course, not how people do behave, but how people should behave. Although this word "should" here, I'm not sure if that's the best one, because as you well know, rationality has been so discussed in JDM that it's basically lost its meaning at this point. I think I'm not a fan of the whole rationality debate, to be generous. And obviously, there are many ways of conceptualizing rationality: mathematical and logical rationality, Tversky-Kahneman, bounded rationality and ecological rationality, Gigerenzer and company. Computational rationality is starting to become a big thing. And personally, I think it would be rather foolish to not acknowledge that all of these are relevant in some sense. I mean, ecological and computational rationality are obviously going to be important because we act in the world and we have limited cognitive resources. But at the same time, we've been sort of butting heads a bit with Gigerenzer and Hertwig and the gang about the mathematical logical rationality, because they tend to either state or at least imply that that's not really important. Well, we, again, me and the lab groups at Warwick would say that yes, it is. It's just not, the the one and only important thing, but in many situations, it will certainly help you get more accurate estimates. But since behavior must be viewed through various lenses, then probably more proper to say that this is about how people could behave rather than how people should behave. So it has less to do with finding the best behavior, because I don't think we can, but rather evaluate the function and the consequence of various ways of behaving according to various rationalities. I won't speak much about various rationalities today, though. I will mainly talk first about the complications that you run into with low probability, high impact events. Some of them are just extensions of complications with probability in general. Some of them are not unique to these events, and at least it emphasized rather strongly in these events. And then again, after this, I will speak a little about ways that we might try and handle this. And this is obviously not an exhaustive list, but I do think that it's some of the what I figured was the most central ones. And I would say that of course, and this is something that might be, something that has been discussed quite a bit, a fair bit about probability in general, certainly about these events, that, we have a problem with estimation. Yeah, there's usually a lot of uncertainty involved, which is also a very natural consequence, because obviously the less often an event occurs, the less data we have. If the event is very rare, then we will get very little knowledge from the outcomes, because the event per definition doesn't occur very often. So that's a problem. It of course means that we might not have a sort of a past sample to rely on, and statistically, and this is sort of an idea of mine that has some colleagues back in Uppsala does not agree with, but I tend to think that from a statistical standpoint, non-occurrence has to be non-informative regardless of the size of the sample, mainly just because regardless of sample size, the maximum likelihood probability estimate, at least if you use some kind of Bayesian framework, will always be 0. And if you have a prior, that actually does not particularly help you, since 0 is always 0. You can, even if you multiply by 0, it doesn't really do anything. You might still have your prior, but the prior will be, well, have this sort of, depends on what your prior is, but basically you won't gain anything from it. You won't be able to update your prior in a reasonable manner. And of course, we can do all sorts of wizardry with extending the reference classes, or in most cases, then use some kind of non-statistical reasoning, some kind of qualitative reasoning to get some kind of probability estimate. But that will, of course, increase uncertainty, because it will be more noisy, more subjective, and so on and so forth. But this is, I'm sure, not particularly new to any of you. But moving on, sort of as an extension of this, and something that Taleb has spoken quite a lot about, we have these heavy tail distributions. Because when we talk about probability estimates and uncertainty, in many cases we can at least assume that we have we have the average, the mean. That's a well-behaved sort of estimator, and it's very good. At least we have that, right? And at least we can maybe illustrate the uncertainty using distributions, and we can, as long as the distributions are themselves rather well behaved. But the problem we run into is with these so-called heavy tail distributions with very large skew or kurtosis, like, for example, Cauchy distribution. I think it's pronounced Cauchy. I'm not entirely certain. And the thing about these distributions is that, as you can see, they have very sort of long tails, meaning that we will get a lot of what we would be considered extreme values in normal distributions, for example. And the thing about that is that, as you can see, we get so large jumps that while in normal cases the mean and the variance will it will converge to the true value, however you want to conceptualize this, in time. But with these distributions, it actually won't, meaning that mean invariance is in some sense undefined. And some people, Taleb, for example, argues that these are much more usual in the world than we think. Whether you agree with that or not, it's certainly the case that, well, this shows that demonstrates very clearly what I think most of us are intuitively aware of anyway, that there are some things that are just not predictable in the statistical sense of the word. So I think it is something that is very important to bear in mind, the limits of statistics, as it were. And of course, limits of statistics puts us very nicely into the limits of expected utility, which tend to not work well at all in these kinds of events. First of all, obviously, to calculate an expected utility, we need the probability and the utility of an event. And if we don't have a valid estimate of either of these, then we obviously don't get a valid expected utility either. But it's also the case that using the expected utility for these events can lead to very weird conclusions. For example, an example here is when the Large Hadron Collider was going to be turned on, there was some discussion and some concern that it might create a strangelet or something like that, and that would somehow annihilate the entire world. Not sure how, not a physicist, but that's something that some people were actually concerned about, and not just anyone, but physicists and people who actually knew things about these things. And there was a paper by Ord, Hillebrand, and Sandberg, which were sort of reasoning about the probability estimate that the researchers gave this to happen, very, very small, as you can see, and sort of reasoning around the uncertainty of this. And I think I don't agree with the conclusions of the paper, really, and I think that some of the reasoning is a bit flawed. But I do think it's an interesting paper, well worth checking out, actually. But one of the most flawed things about it, I think, was how they used expected utility in this, meaning that if you multiply 6.5 billion people, the population of the world, with this probability that I had, that would essentially equate an expected loss, I guess you would say, of 1,000 people, implying that it would be more or less equivalent turning the Large Hadron Collider on to signing the death warrant of 1,000 people, which I think is just seems like nonsense to me. So it just doesn't seem to work. And there is, of course, also a philosophical conundrum in that expected utility is per definition a frequentist concept, I would argue, because the expectation is, after all, conceptually the expectation over a long period of time, repetitions of this event. And this is many times not applicable. And of course, that's not a new thing at all. Gigerans and others have said this many times. But I do think that you sort of run into it. It's of particular importance for these kinds of events, because it sort of, if nothing else, it casts particular light on this problem. If you, for example, ask yourself the question, well, should I insure my house against house fire? Then, well, I mean, you could check the frequency of house fires in your area or equivalent to get some kind of probability estimate. You could also calculate the value of your house and see how much you would lose. And obviously, that would just be an expected monetary loss. Losing your house, large emotional trauma, of course. But in this case, you could do that and then compare that loss against the cost of the insurance. But I would argue that that doesn't quite make a lot of sense, because this expected loss from the house fire, that's the one thing that you're pretty sure of won't occur. I mean, presumably either your house will burn down or it won't. Well, maybe you can have sort of a localized fire in the garden shed or something like that, but generally that's not what we're concerned with. And of course, you can't get around the fact that if your house burns down, then you really want the insurance. If the house doesn't burn down, then it's just throwing money away for no reason. And in the end, you don't know which of these will occur. So you need to some way of figuring this out, but I'm not sure that expected utility or expected value in this case helps us, because that number I don't think really tells us all that much personally. But this also gets us onto the third point I want to make here, which is about the conceptualization of probability. So one might ask himself, well, if this really makes a difference, well, how should we conceptualize probability? Problem is that no one knows. There's a lot of philosophical interpretations of probability, and I want to emphasize here, this is not just the case that none of these are sort of the obviously best one, but it's also the case that none of these actually fulfill all the philosophical and mathematical criteria that we would want in a philosophical definition of probability. The ones that we usually think about is probably, the frequency interpretation and the subjective interpretation, which is sometimes called the Bayesian probability interpretation, which I personally don't think is quite correct. No such thing about that as Bayesian probability as such, but I won't go into that because it's all semantics and it's not really important. You probably have your favorite of these, I know I do. But of course, the question that you need to ask then is, well, does this actually matter? Because probability theory, the mathematics, that's all the same regardless of how we think about it, right? And it works. We know that it works very well. It's giving us a lot of things, a lot of advancements, scientific advancements. And I believe that it does matter to some extent, because the conceptualization of probability will affect how you can assign probability in the first place, which probability theory actually does not give us any information of. And I wanted to illustrate this with the Sleeping Beauty problem, which is something that has fascinated me quite long. And I think we have time to go through it, and I think we should, because it's interesting. Basically, the idea is that, imagine the following. Some researchers are going to put you to sleep. During the 2 days that the sleep will last, they will briefly wake you up once or twice, depending on the toss of a fair coin. So if they will toss the coin, you won't see the coin. If the coin ends up heads, they will wake you up once. The coin ends up tails, they will wake you up twice. And after each time you wake up, you will be given a drug that makes you forget that you've woken up. So, every time you wake up, you will not know if you have been woken up once before or not. And when you are first awakened, not sure of the choice of the word first there, but it's just a quotation. To what degree ought you believe that the outcome of the coin toss was heads? I think maybe do a short experiment little. So how many think that you should believe that the probability of or your credence, I should say, that the coin was heads is 1 in 2, 50%? Anyone? Yeah. How many thinks that it's 1 in 3, like approximately 33? Yeah. Some people there. Good. I was hoping that we'll get both answers, because that's generally what happens for this problem. And of course, both of them have quite good reasoning behind it. On the one hand, you could think that, well, the probability of a fair coin is always 1/2, because we know that coin is fair, that's per definition, and we receive no other information, so it's still just 1/2, right? On the other hand, if the experiment was repeated many times, then each time you wake, approximately 1/3 of these times would be when the coin landed heads, a very reasonable, traditional frequentist interpretation. And these two positions have, amusingly enough, created a huge metric buttload of papers. There's a lot of people having very strong opinions about this, and the two camps are very, very surprisingly hard, well entrenched, and it seems to be almost impossible to change someone's mind when they set their mind to one of these interpretations. Of course, as you may already have sort of thought about, which certainly I myself am inclined to believe that this is really the case where, well, one might argue that the problem is underspecified. And that would certainly not be incorrect. I prefer to see it, though, that it sort of demonstrates the malleability of probability, and it demonstrates that we need to take into account how how we use probability before we can get, you know, an answer from this. One might argue that halfers, as they called, take the experimenter's view, while others take the subject's view. So sort of do you focus on the coin or the weight? Actually, and it's actually the case that in terms of Brier score, which is a proper scoring rule, 1/2 minimizes average inaccuracy, while 1/3 minimizes total inaccuracy. And that sounds somewhat insane. Then I would agree. I've talked about this problem several times before, and every time I look at this slide, I look at that sentence and think that can't possibly be right. But so every time I have to recheck the paper where this is brought up, and I do think it is actually, even though it still makes no sense to me. Mm-hmm. But the crucial point here is that both perspectives are rationally permissible and make sense just from different perspectives. Okay, so that's all fun and fun and games, well and good. But what's the point here, really? Well, the point, and a point that I think is not given enough attention at all, is that probability cannot be defined solely by mathematics, with which I mean, you know, Kolmogorov's axioms, traditional axioms that we base probability theory on. But rather it's always based in sort of a context. And crucially, there are probability theory actually includes no formal method of assigning probabilities. It's extremely well defined as long as we have the numbers already, but it gives us absolutely no information at all at how to get to these numbers. It does, you know, in Kolmogorov's original formulation, it's certainly a requirement that a probability must, you know, in the long run, approach the, you know, the proportion of outcomes in a large sample. But that's not the definition of probability. That's not what a probability is according to Kolmogorov. It is according to the frequentist perspective, but that's part of the problem with the frequentist perspective. You have a circularity. You define probability according to the same metric by which you sort of evaluate the accuracy of a probability, which isn't really ideal. And why is this important? Well, I think it's particularly important for these events because we do not generally have very well-defined outcome distributions to rely on. We can't really, you know, update our accuracy as we go along, which we can for quite a few other types of events. But rather we need to assign probabilities from in some other way. And of course, in that case, it becomes quite important how we do these assignments. And I think that if we do focus and put this in you know, its proper perspective, that will make the uncertainty of these estimates much more transparent. So I do think that this is a very important aspect. And I think for example, in particular, I should say, because you know, probability estimates and numbers in general is something that when people see them, there is a tendency to trust them perhaps more than you should. Now I'm reminded of this quite a lot nowadays when we have, you know, people are talking a lot about artificial intelligence, and some people are concerned about artificial intelligence becoming an existential threat to humanity, maybe even an existential threat. And you get these sort of articles where in the newspapers where there's panel of AI experts says that there is so-and-so probability of humanity being wiped out by artificial intelligence within the next decade or something like that. And that always tends to drive me completely up the wall, because it is clearly in this case an estimate that is based on their subjective, you know, personal assumptions. Certainly there are cases in which we have rather good and well-defined models, like climate change, for example, in which case we should, you know, trust the estimate. But in this particular case, I think that if we actually looked at how these, you know, probability estimates, I should say, came about, then that would tell us quite a lot about the uncertainty in this. because what it is basically just some people are very scared about this, which I think is not the same thing as trying to actually communicate some information that's relevant to the general public. So it's already 11:45, so I might rush through this a bit, but I of course need to mention some of the potential mitigation strategies, I've come to call them, for potentially coming to terms with some of these problems to some extent. Of course, I need to mention heuristics, because it is apparently, I think quite apparently, at least part of what people actually do. And obviously there is often the idea that heuristics are, following, again, Giger and Hartwig and people writing from the same perspective, that heuristics are very good, they're very useful, they're very efficient, and in many cases I do think that that's certainly the case. But in these cases, well, heuristics are always based on ignoring information to some extent to sort of improve efficiency or deal with uncertainty. And when the stakes are as high as they are with these events, I think that is arguably unwise. But also in that it just doesn't seem to work that well, does it? I mean, we still have people making very weird and sometimes unwise decisions. So I think there's quite, if this is how people work, then I think that there's something that could be done to improve that. One sort of way to approach maybe a bit more sensible way is by rankings and comparisons, because that is, rankings is actually something that has been found is much more reliable and generally matches reality better than absolute likelihood. Certainly when you just elicit it from people, they tend to be more stable. It's also can be rather useful in practical sense for resource allocation. If you have a number of accidents that you're worried about, which one should you prioritize mitigating? Well, given that you can either assume comparable impact, or maybe the impact is very uncertain in the first place, then prioritizing the most likely one first seems sensible. And in this case, you might not need to know the exact probability. So that's one way of coming around it. Of course, that implies that we need to have events that are actually relevant and comparable, and it doesn't eliminate that you can still from an absolute perspective still just discount all of them. And of course in that case it doesn't really matter how you rank them if you're not going to care about it in the first place. Minimax is one of these decision rules that are used in I think artificial intelligence and game theory, areas like that, where you and it's for decision making, obviously, and the idea is that you want to minimize the maximum loss. So in other words, you want to find the option with the best worst case scenario, basically. And so for example, when the COVID pandemic was just starting, sort of in March 2020, then there was it was apparent that something was going on, but it was very unclear how serious this was going to be. And I was in the UK at that point, as said before. And there was a lot of sort of discussion about from the government and in academia. Certainly people were saying, well, what do we do? Do we, go into lockdown? Do we not? And so stuff like that. And so Nix wrote a short sort of opinion piece sent into The Guardian, arguing from this kind of perspective that, well, if we look at it like this, if we do go into lockdown and it turns out that pandemic is really just a tempest in a teapot, worst case scenario is that we messes with the economy, we disrupt people's life. That's what, and I mean that's obviously not good, but that's still the worst case scenario. On the other hand, the pandemic turns out to be a big thing, which of course we know now that it certainly turned out to be, then the worst case scenario is well a lot of people going to die, and there's going to be general chaos and everything. And of course, in that sense, this is and I personally think that that's a very sensible way of viewing at it. And of course, the UK did go into lockdown eventually, but I think it's quite clear that it would have been better if they had done that sooner. But this can be very useful in situations with very high uncertainty, because of course in that case what is the pandemic going to turn out to be like? We really have no idea. It's so much uncertain that we will not be able to say. But on the other hand, this can turn very counterintuitive where we have very small probabilities. For example, going back to the Large Hadron Collider again, what's the worst case scenario there? Well, annihilation of the Earth. Well, I mean, using the minimax rule, obviously you shouldn't flip the switch. But again, I think that's, to me, that's a counterintuitive conclusion, because, well, really, you can't just not do anything because it might lead to disaster. Because when you come to these very small probabilities, very many things can potentially lead to disaster. Right. Just briefly mention the fourth quadrant, which is Taleb's ideas, where he sort of combines the nature of the distribution with the nature of the outcomes. And the point is basically that in 3 of these 4 quadrants, we can generally use statistics and prediction to protect against black swan events, because we can reliably predict either sort of propensities or frequencies of outcome, or we can predict the outcomes themselves. And so we have some basis of mitigation. But in the 4th quadrant, we can't do this. And of course, the trick is identifying when we are in the 4th quadrant and when not. And I do think that this conceptualization can be very useful because, as we've seen before, all of these tools won't work in all the situations. And these kinds of sort of categorizations might help us to realize which tools to use when. And I wish I had a bit more time, but I will try to explain possibility theory in a few minutes. It might not be, well, you can just ask me about it afterwards if you're so inclined. But basically, possibility theory is it's not very well known, I don't think, but I find it rather interesting. It's an alternative to probability theory. It's also mathematically well defined. It's based on clear axioms, so it has that in common with probability theory. But whereas probability theory uses 1 number, possibility theory uses 2 numbers. So rather than saying, well, how probable is an event, you say on the one hand, how possible is it, how necessary is it? I'll try to sort of demonstrate a bit of what that entails. It's still the case that both these numbers are defined on a scale from 0 to 1. And if something has a necessity of 1, it's certainly true, it must also have a possibility of 1, because something that is necessary must also be possible. If it has a possibility of 0, then it's certainly false. It must have a necessity of 0, because something that is impossible can't be necessary. If it has a possibility of 1, necessity is unconstrained. And if it has a necessity of 0, then possibility is unconstrained. Basically, as you might have realized already, either possibility or necessity or both has to be 0 or 1. And just as an example of this, we can look at, for example, well, say Joe Biden winning sort of the 2nd term as a US president. I would say that's certainly entirely possible, because I mean he's there, he's running. It's nothing that would prevent him. So that would be a possibility 1, right? Entirely possible, not entirely necessary, though, because good chances, I'm sure, but of course, as we have seen before, it's hard to predict these things, and you get swings in various directions. So necessity is somewhere between 0 and 1. On the other hand, let's say that we look on the event that I personally would win the next US presidential election. Well, I mean, in theory, possibly if I somehow faked a US citizenship and so on and so forth, but it's certainly nothing like necessary, particularly since I have no intention of doing this kind of thing. So probably the possibility is somewhere between 0 and 1, or for that matter, let's say me beating the world record in long jump, maybe an even better example, because is that possible? I don't know, really. I mean, I'm rather short, and I'm certainly not as fit as you probably have to be. So also possibility somewhere between 0 and 1, closer to 0 probably. And what's the point of this? Well, I think an interesting aspect of this is that it sort of gives you some more detailed view of the various ways that you can conceptualize probability. So, for example, in this case, you can actually express complete ignorance in a very nice way by saying that something is entirely possible but entirely unnecessary. What's going to happen? No idea. Who knows? And of course, in probability theory, you would either say, well, the probability is 50%, but that's not really a good thing to say, because that also kind of implies that you know that the probability is exactly 50%. And that's not always the case. You can also just say that the probability is undefined, but of course, that doesn't really help you very much. So I think that I certainly don't think that possibility theory is sort of a solution to all of these problems. And I think it probably has problems of its own. But I do think it's an interesting example of, other ways to think about these things. So, summing up just very briefly, I think that in the case of low probability, high impact events, they emphasizes the limits of probability and implies particular complications of their own. There are ways to mitigate these complications, but they are certainly also limited and or heavily context dependent. And also I should, of course, point out the list here of sort of ways to deal with this is by no means exhaustive. It's just things that I've come across that I felt relevant to bring up. So that's certainly one case where I'm very much welcome input on. And I tend to think that the most promising direction in this case, it would be measures and classifications beyond standard probability theory. I won't say outside of, because not necessarily the case. I don't think that we should throw the baby out with the bathwater, essentially. I think that probability and probability theory still has its place, and that's probably where I mostly differ from Gigerenzer and Hertwig and those people, who I bring up quite a lot because they have said a lot of similar things. But I do think that they tend to, I do think that they tend to ignore the tools and the possibilities that probability theory does give to us. So I think a sort of a synthesis of perspectives would probably be more useful here. And that's it. I'll keep this slide up in case someone wants to write down one of those links or something. But yes, thank you for your attention. Sorry about taking a bit longer than I was supposed to. Hopefully it was interesting. And yeah, questions, please.
Can I ask you about whether the problems you identified really come from low probability, high impact? Because it seems to me there are some low probability, high impact cases that are entirely straightforward to think about. And if that's right, that suggests that the problems you're talking about might come from other sources, like 19 uncertainty or something like that.
Oh yes.
So the particular example I was thinking of is lottery. So there it's a positive impact event, different from many of yours, but still, the chance that I will win the jackpot if I buy a lottery ticket right now, I mean, it's a low probability. It would transform my life, but I see no major conceptual problems related to any of that.
No, that's. Thank you for bringing that up, because that's a very good point. I don't want to sort of get the impression that I think that low probability, high impact events are always impossible to conceptualize or anything like that. It's more the case that I think that those events are often that and sort of emphasize that general tendency in probability. But I do agree with you. Where I do think that these more well-defined low probability, high impact events, there are still some problems in figuring out exactly how to talk about the rationality of the behavior. Well, for example, the lottery example I think is a good one, because that's certainly a case where in one perspective, you can't expect to actually win anything from it. So most sensible people say, well, just a scam, it's not worth your time. But I have a colleague who's also, very, like all of us, very, very well versed in probability, that reasons that, well, yes, of course, that is true. But buying a lottery ticket now and then will make no discernible impact on my finances. And that way I do open the door for something extraordinary to happen, which is guaranteed not to if I don't buy the lottery tickets. So I do agree with you, but I think that even in those cases, there are sort of it's still not clear how you're sort of, again, I don't want to use the word supposed to think about it, but there are sort of complications that you might not run into when it comes to more moderate degrees of probability and impact.
With the part that you were talking about, people making a decision, like the probability of AI taking over, and you have this, you know, you're saying it's too subjective, they're making this decision based on their life experience or whatever it might be. You're also saying that the shouldn't define the probability solely on mathematics. So what other things can you use that won't be subjective, that won't be purely mathematics?
Oh yes, I mean no, you're absolutely right. It's certainly the case that, you know, in the end, for many things, and certainly in the case of AI, taking over the world, you have to do, use the very least, qualitative reasoning for it. And I do believe that will have to, in the end, be subjective, because you're making a subjective assumption on what kind of, how you do this. Even if you have some kind of formal framework for it, you still make decisions, and it's still subjective in sort of the long run. And I don't, again, glad you brought it up, because I don't want to give the impression that this is always bad. Certainly not the case, and sometimes that's all we have, and that's fine, and then I think we should use it, and I don't think that there's a problem with that as such. But I do think that this should be, clear. I think that when you communicate probability estimates to the public, you should make clear how these estimates are assigned. And this doesn't need to be anything complicated, but just maybe a short sentence or two, sort of based on these and these and these considerations. The expert's opinion is that, something like that.